Okay. So we may learn several type of measurement methods. Okay. Uh, when we want to monitor either the performance of the slope or during the construction of the embankment. Okay. So for the instrumentation monitoring, there will be a three type of common instrumentation, which is to measure and monitor. The first one is the climatic condition, normally related to a rain, especially in Malaysia. Hydrological parameter, we want to determine what we call as the soil conditions, in terms of the hydrological parameter. And the last one is the kinematic parameter, where we want to monitor for any movement happen inside the soil or inside the slope structure. So for the climatic condition, so we may use a rain gauge, to capture the number of the rain, at a certain area, or by using a radar, to determine the amount of water in cloud, and the last thing is by using a satellite, to predict, when will the rain fall at that particular area. Okay. But in terms of quantitative, so for the cheapest part, by using a common rain gauge methods. So then for the hydrological parameter, where we used several type of instrument. The first one is the piezometer, where we want to determine the groundwater level and also the pressure of the water. So we have here time domain reflectometry, to monitor for the soil moisture content. And the last one is the tensiometer, where we want to determine the soil suction. And it's very important for the unsaturated soil mechanics study. So for the kinematic parameter, we have several type of measurement. Inclinometer to determine for any incline happen on the slope or any horizontal movement. So then we also have a tilt meter, to determine the same movement under the horizontal movement. So then we have an extensiometer, where we want to determine the vertical movement. Strain meter, to determine for any strain happen. Then we may convert to stress, after we know what will be the material or the behavior of the material. So on the top of the soil, we may use a survey marker, to determine for any ground movement at the top. Then we have a global positioning system to translate into velocity or acceleration, or at the same time we may determine the positions of the area, or any movement based on the different positions. So this is some of the example of the device that commonly been used, where we have a road settlement gauge, deep leveling datum. So these both instrument need to install inside the slope or embankment structure. Then we have piezometer, to determine the pore water pressure, or the water level. So then we have another one, which is the standpipe piezometer. So this piezometer or this standpipe only able to measure the what we call as the groundwater level, not the pore water pressure. Okay, so then we have another one is the inclinometer. Okay, so to determine for any lateral movement. Okay, so this is a magnetic extensiometer. Okay, just to determine the vertical movement. Okay, while this is the horizontal movement for the under inclinometer. Then we have a settlement marker. Okay, to determine for any movement at the ground level. Okay. Okay, so this example of the rainfall, okay, and also with the inclinometer reading. Okay, so from there we can identify, okay, what is the influence of the rainfall, okay, and how many infiltration happen, okay, inside the rainfall, okay, and also we may determine is there any movement happen, okay, at the slope area. Okay, so this is inclinometer. We react, okay, to determine the movement. Okay, while this cumulative rainfall, we determine what will be the rainfall intensity. Okay. While this is the value, okay, to determine the ground, the what we call the increment of the pore water pressure, and it may reflect to the groundwater level. Okay, so when we correlate all these result, okay, so we can identify or we can investigate, okay, what may cause for the, for example, for the failure of the slope, okay, which is most probably due to the high intensity of rainfall. Okay. Okay. So this is an example for a field test, okay, when the author, okay, show on the method used, okay, to observe or to determine the behavior of the slope conditions. Okay, so this is what the type of the tensiometer. Okay, so this is the rainfall gauge. Okay. Okay, hydrological parameter, kinematic parameter, they have two types of kinematic, lateral and vertical. Okay, for the pore water pressure, okay, so the author have list, okay, reason for monitoring. Okay, determine the safe rate of fill, predict slope stability, okay, design and build for lateral earth pressure, design and build for uplift pressure, monitor the effectiveness of drainage scheme. Okay, so the method that we use is the vibrating wire piezometer, VW piezometer, pneumatic piezometer, and the last one is the standpipe piezometer. Okay, so for the lateral deformation, evaluate the stability of the slope embankment, determine the need and timing for corrective measure, verify the performance and the safety of structures such as retaining wall and embankment. Okay, so how to capture or to determine the lateral movement by using the inclinometer and the road extensiometer. Okay, so the last one is the vertical deformation. Okay, so the reason for monitor is to verify the soil condition is proceeding as predicted. Okay, predict and adjust the final grade of embankment, verify the performance of engineered foundation. The last one is determine the need and timing for corrective measure. Okay, so the type of the instrument, settlement cell, magnet, extensiometer, Sondag, settlement point, road extension meter, horizontal inclinometer. Okay. So failure mechanism. Okay, there are three main embankment or slope failure mechanism considered. Okay. The first one is the rotational stability. Okay. Then they have a lateral sliding here. And so there's a lateral sliding here. Okay. And there is a bearing capacity. Okay. So we need to determine the value for each failure mechanism, okay, in order to make sure that the embankment is safe, okay, uh, to be used. Okay. 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 So we have discussed previously on the construction of the embankment. Okay, so this is bearing capacity and settlement calculation. Okay, so we may monitor for what will be the allowable bearing capacity. Okay, due to 2 meter height of embankment, 4 meter height of embankment, and 8 meter height of embankment. So this is the chainage to determine the distance between each chainage. Okay. So then there is a settlement measurement, okay, which is based on the location of the borehole. Okay, they have borehole 2 until borehole 22. See, so this is the amount of settlement, okay, due to the embankment height of 2 meter, 4 meter, and 8 meter height. So it is recommended to use the PVD with a surcharge. Okay. So they put in the remark. Okay. So scope of work. Okay. So this example, okay, on how to propose for any instrumentation work. Okay. Okay. Then there we have a foundations. Okay, and also the embankment. Okay. So this is the instrument, okay, used, okay, to look on the on the foundation, okay, and the above the green box, okay, all the instrumentation used to what we call as to monitor for the performance of the embankment field. Okay, so for the foundation soil, okay, so there will two set of inclinometer, okay, especially to monitor for any lateral movement, okay, happen on the foundation. And also at the center is a pneumatic cylinder piezometer, okay, to ensure the stability of the embankment, okay, under the what we call as under the pore water pressure measurement, okay. So we cannot increase what we call as the pore water pressure exceed, okay, from exceed a very extreme value from the uh, calculated pore water pressure, okay, line. Okay. Okay, for example, this is the pore water pressure line. Okay. So when we increase the load, okay, so there will be a significant different or increase of the pore water pressure. Okay. So we need to make sure that the movement, sorry, the the additional of pore water pressure, okay, so should not exceed, if I'm not mistaken, 0.7 or 70%. Okay, differ from the calculated pore water pressure. Okay, so if exceed, okay, so need to uh, stop what we call as the construction of the embankment. Okay, let it reduce, okay, less than 70%, okay, for a while, okay, before we install or reload with higher embankment load. Okay, so for the embankment field, okay, here we have a settlement marker, which is SM, okay, installed on the top of the slope or top of the embankment, and also at the edge of the embankment, okay, to monitor for any vertical movement. Okay. So selection of instrument, okay. So settlement marker will be installed at the embankment field to monitor for the vertical movement. Okay, for the foundation, there will be also settlement gauge, okay, to monitor for the vertical movement. Okay, horizontal movement will be monitored by inclinometer. Piezometer and also water standpipe will be used to measure the pore water pressure and groundwater level respectively. Okay. So conventional survey, okay, at the same time, okay, we may use a conventional method, okay, to monitor for any movement, okay, on the surface of the, what we call it, of the slope. Okay. So for the surface, we may use the conventional survey by using a settlement marker approach. Okay. So install a monitoring point using total station or differential GPS, determine rate of movement. Okay. So this is settlement marker where we install on the surface of the ground. Okay. Then by using a surveying method, so we can determine what will be the movement under vertical reaction. Okay. So okay, so this is the settlement marker. Okay. So then we may put a survey instrument, okay, a leveling instrument. Okay, then the surveyor may use a total station, okay, to look for any movement. Okay. So it should be conducted periodically, okay, to get or to calculate for any cumulative movement. Okay, so normally for every 1 month, so they will carry out for the surveying work. Okay, so this is example of the settlement marker. So normally installed at the ground surface. Okay, so from there we can determine either it is heave. Okay, the heave is related to the movement of the soil, okay, in a positive value or greater than the ground level, while for the settlement it will be a negative value or below the ground level. So this is the road settlement gauge, okay, normally installed before the construction of the embankment. Okay. So this settlement will be put on the foundation, on the soil, existing soil. Then during the filling process, okay, so we may use to monitor for the any vertical movement. Okay. So this is the calculation. This is a graph to show that, okay, during the filling process, okay, what will be the settlement value. Okay. So then until we have complete the filling process, so there will be no settlement happen. Okay. So means that there are no immediate settlement, okay, right after complete for the fill height installation. Okay. So later on, it may continue with the primary consolidation. So this is related to the primary consolidation. Okay. So later on, there will be a movement, okay, due to the loading process. So there will be two different, okay, between the road settlement gauge and magnetic extensiometer, okay, where the extensiometer, we can determine the movement, okay, at a certain height of a soil, okay. While for the another one, the installation of the settlement plate, okay, we may install on the ground level, okay, or inside the filling area or before the filling area. While for the magnetic extensiometer, okay, it is installed beneath the ground level. Okay, so this is the ground level, while this is the ground level. Okay, so it has it has two main difference. Okay, first in terms of the installation, second in terms of the value that can be obtained. Okay, so that's why they call a spider magnet. Okay, so for example, if you want to look for any difference in this particular area, okay, so we use this magnetic indicator. Okay, so when the magnetic indicator, okay, that have a sensing probe, so it can get the value of this spider magnet, okay, because it consists of magnetic instrument, a magnetic device. Okay. Okay, so then we have a water standpipe. Okay, used to measure groundwater table in the slope. Do not measure pore water pressure. Okay. Determine the change in the groundwater table. Range depth depends on borehole. Accuracy 1 centimeter or depending on deep meter. Okay. So the main difference between the pore water pressure or piezometer with the water standpipe, the water standpipe would not measure for the pore water pressure, but for the piezometer, it can measure for the water level and also the pore water pressure. So this example of the piezometer, this example for the standpipe. Okay. Either we use a graduated probe, a graduated tape with a probe, or we can use a distometer, okay, to get the value or the height of the water. Okay. So this is the pore water pressure. Once we know where is the height of the groundwater level. Okay. So this is a piezometer. Okay, measure groundwater level and also measure the pore water pressure. Three type: open standpipe, pneumatic, and vibrating wire. So the installations of the piezometer as shown in this diagram. Okay. In order to make sure that the piezometer, okay, is touch the bottom of the soil, bottom of the hole. Okay. So either we use a countering uplift, or we use a 3 pipe, okay, and then we use a grouting, okay, to make sure that it doesn't move later on, okay. So this is the piezometer, okay. So actually we can measure for a different height, okay, by installing 2 or 3 piezometer device. Okay. If our intention to get uh, the what we call as the height, sorry, the different height, uh, different pour water pressure at a different height. Okay. Or is there any significance of water movement inside the soil? Okay, so we may install 2 or 3 piezometer. So this is the what we call the diagram to show that the reading for the pour water pressure, okay, versus with the times. Okay, so this is the difference that I mentioned here. Okay, when we do a loading, so the pour water pressure will be increased. Okay, so we need to measure, or we need to make sure that it doesn't greater than certain value. Okay, otherwise, the embankment will be collapsed. Okay, so this is the difference between water standpipe and piezometer standpipe. Okay, so water standpipe is a normal standpipe to measure the groundwater level. Okay, while the piezometer standpipe can measure the water level and also the pour water pressure. Okay. So this is the inclinometer, okay, where we want to determine what we call as the lateral movement. Okay, so this is the cap. Okay, so we may uh, make sure that it should be closed, and we use a lock. Okay, we need to lock. Okay, so we may monitor, okay, for a several period. Okay, so it may depends on the type of the material that used. Okay, so what is the uh, how long it can extend inside the soil. Okay, okay, so this is the inclinometer. Okay, so normally we put on, okay, to measure. We are used to measure for the horizontal movement. Okay. So this is the system that will be put in place. Okay, while there is another method. Okay, so this method, okay, that can be retrievable, okay, after do the measurement. Okay, okay, so this groove, okay, is made, okay, to allow for this inclinometer, okay, to be input inside the tubes, okay, so that they can determine what is the movement happen. Okay, so this groove, okay, is allow for the inclinometer to be included during the measuring process. Okay, so this is the inclinometer. Okay, so they will measure, okay, the incline of the soil, okay, after the installations, okay, for a certain period of time. Okay, so if it doesn't have any movement, so the value should be same with the previous one during the installation process or during the datum, called as a datum. So then we can get what will be the incline value. This is the incline, angle of inclination. Okay. Okay, so this example of the reading for an inclinometer. Okay, so this is how they plot the data. Okay, settlement gauge, inclinometer. Okay, at the same time, the field thickness value. Okay, to monitor in order to make sure that there will be no large movement. Okay, due to the filling process. Okay, so they need to measure. Okay, if there is a large movement, so they need to stop for the filling process. Okay. So what monitor data to be collected? When monitor data to be collected? How to determine monitoring work? Okay. So this example of the embankment. Okay, then they put the what we call the instrumentation device. Okay. So schedule of instrumentation. Okay. So in here, the author suggested. Okay. For how many frequency, okay, that should the contractor get the reading. Okay, so during filling work up to formation level, the reading should be recorded after each change in loading. Okay, not to be less than 2 times per week. The next 4 weeks after completion of filling work, every 3 days. Okay, so the filling process is the most important. So we should have a very frequent data collection. Okay, so it will be reduced. Okay, after the filling completed. Okay, so then for next 12 week, 1 week per trip. Next week 12 week. So we should have a trip of 2 weeks for every 2 weeks. Okay. Okay. So this is the result from the settlement monitoring. Okay. Okay, this is the result for the stage construction, which is stage referred to during the installation, during the filling process. Okay. So need to monitor for any movement, the soil, or pore water pressure as well. So this is another method, okay, where they use the ASOCA method. Actually, you may learn, okay, for the postgraduate student, you may learn, okay, on one or I'm not sure about which subject that you may learn on the ASOCA method, okay, but you may learn during your master program. Okay. We may compare the result that we obtain, okay, from the site, okay, and then we may compare with the previous or the future value from the same site as well to plot the ASOCA settlement. I will not explain in detail for this method, okay, because you may learn in another subject. Okay. So termination of settlement or monitoring work, okay. So when it complete for the primary settlement, so it's not necessary for us to continue for the monitoring process. So groundwater and pore water pressure monitoring, okay. So this is example of the pore water pressure development, okay, during the filling process. So if we control it carefully, okay, so there will be no significant of pore water pressure development. Okay. So if I'm not mistaken, yeah, the process should be gradually increased for less than 1 meter for every filling process. Okay. Okay, so this example, okay, of the uh, uh, monitoring of the pore water pressure, okay, for the stage 1, okay, and then continue with the stage 2. Okay, so we need to look on the piezometer or the pore water pressure result. Okay. Okay, pore water pressure development. Okay, so there will be an increment of pore water pressure, okay, during the feeding process. Okay, this is for the horizontal deformation, which is from the inclinometer. Okay, this is how they show the inclinometer works. Okay, due to the ground move slope failure. So we need to make sure that the inclinometer is greater than the length of the inclinometer should greater than the slip plane. Okay. So in that case, we can get the value for the horizontal deformation, okay, correctly. So the blue one is before failure and the red one is after failure. Okay, this is the reading from the inclinometer, which is this base reading, okay, before the any movement happen, okay, then it start to move a little bit and then back to the base, okay, and then another movement, okay, after almost 1 year of installations, okay. Okay, construction monitoring, okay, so this is the value, okay, that should not be exceeded, okay, during the monitoring during the installation of during the filling process. Okay. So if the value is exceeded, so means that what we call it can contribute to the failure. Okay. Okay. So for example, so that not exceed 0.2, okay, for the maximum speed over maximum vertical depth. Okay. Well, this is for the pore water pressure. Okay. Change in pore water pressure and increase in embankment pressure. Okay. So we need to compare, okay, the result from the piezometer, okay, and the result from the field load. Okay. So it should not exceed 0.7. Okay. The last one is the equation for the inclinometer over strain gauge value. Okay. So it should not exceed 0.2, 0.5. Okay. So that's why it's very important to monitor during the feeding process. Okay, assessment of the ground improvement by field test. Okay, so this is we do a ground treatment. Okay, so we may check the increment okay, of the soil. Okay, change the consistency of the soil, very soft, medium, stiff to very stiff. So is there any significant happen, okay, due to the improvement process? Okay, we may check using the SPT test. So assessment, okay, by using the CPU test, okay, code penetration test, okay, to check is there any improvement, okay, due to the ground improvement, okay. So we can identify, okay, for example, line A improve, okay, line B improve, while line C doesn't show any improvement, okay, because the CPT or the tip resistance value is very low. Okay. Okay, then we may we may compare with the odometer test. Okay. Either the material is already stiff or not. Okay, due to the improvement process. Okay. So we may use the SPT, we may use the CPT, or we may use the odometer where we obtain from the undisturbed sample. Okay. So this is the value of the CC, okay, and also okay, the higher CC, the greater the highest CC, the lower of the improvement process. Okay. So the less CC is better. Okay. Okay. So that's all. Okay, for the instrumentation, uh, for the embankment or for the slope uh, monitoring process. Okay.